Hello everyone, in this video we are going to see Friedel-Crafts reaction. What is Friedel-Crafts reaction? So it is a organic coupling reaction which involves the electrophilic aromatic substitution and which is basically used to introduce a alkyl or acyl substituent to the aromatic ring. So there are two types of Friedel-Crafts reaction. One is Friedel-Crafts alkylation, so in which alkyl group is substituted to the aromatic ring. And another one is Friedel-Crafts acylation, so in which a acyl group is substituted to the aromatic ring. And in the Friedel-Crafts reaction we use a catalyst. Let's see what catalyst we use it. So we use aluminum trichloride or ferric chloride as a catalyst. So whenever you see a reaction, that is a electrophilic substitution taking place in presence of these catalysts, then most probably it is a Friedel-Crafts reaction. And why we are using this catalyst in this reaction is these catalysts acts as a Lewis acid. That is, they accept a lone pair of electron, and therefore it helps in the formation of an electrophile. Okay. So which is basically the first step in the Friedel-Crafts reaction. Now let's see the mechanism of a Friedel-Crafts acylation. First step is formation of electrophile. So here the ACYLIUM ion is an electrophile. So the Lewis acid catalyst, that is the aluminum trichloride, it reacts with the acyl halide and forms a complex, and in that complex, so first look at this reaction. So here, so the acyl chloride, so that is your RC double bond O Cl, it reacts with the aluminum trichloride and forms a complex. Okay. So once this complex is formed, this chloride ion is removed. It goes away with this aluminum trichloride and resulting in the formation of your electrophile, that is your ACYLIUM ion. So next is the acyl halide loses its halide ion and forms ACYLIUM ion, and which is then stabilized by resonance. Okay, this ACYLIUM ion is stable because of resonance. The second step is electrophilic attack on the aromatic ring. So the ACYLIUM ion, which is an electrophile, which attacks the aromatic ring, which results in the formation of a complex. So look at here. So across this double bond, this ACYLIUM ion is added across this double bond, and hence the aromaticity is lost. Okay. So next, third step is deprotonation. So this deprotonation is done to regain the aromaticity of the ring. Okay. So proton attached in here. So this proton, it leaves, and so this proton, it leaves and forms a bond here. So the ring regains its aromaticity and forms a ketone, and this proton goes away with the chloride, so which was formed in the complex, and once again the catalyst is regenerated. So the third step, deprotonation takes place, which regains the aromaticity, and the regeneration of a catalyst takes place. So next, fourth step is the formation of acyl benzene. So the regenerated catalyst can once again react with the carbonyl oxygen to form a complex. So this catalyst is again capable of reacting with the are capable of accepting a lone pair of electron, and it can again forms a complex. To avoid this thing, we are treating it with excess of water, so that this forms as a aluminium salt. The catalyst is catalyst forms a aluminium salt, and acyl benzene is formed. Okay. So the overall reaction of Friedel-Crafts acylation is, so look at here. So benzene aromatic ring, which reacts with the benzyl chloride in presence of anhydrous aluminum chloride and forms a benzophenone. So here the acyl group COC6H5, this acyl group COC6H5 is substituted in the ring. So benzophenone is formed. So this is the overall reaction of Friedel-Crafts acylation. Now let's see the limitation of Friedel-Crafts acylation. So it can be only used to give ketones. So this is capable of giving only ketones. This is because HCOCl, it decomposes to carbon monoxide and hydrochloric acid under the reaction condition. So it forms only the ketones, not the aldehyde. So if we want aldehyde, we should start with the formal chloride. So when in this reaction condition, this formal chloride decomposes to carbon monoxide and HCl. So only option left out is ketone. And next one, so the deactivated benzenes are not reactive to Friedel-Crafts reaction. So that is a substituents, so which prevents the addition of an which prevents the electrophilic attack. So in those substituted rings, we cannot they cannot undergo Friedel-Crafts reaction. And next, the Lewis acid catalyst ALCl3 aluminum trichloride, they often forms a complex with aryl amines, so making them very unreactive. So when the Friedel-Crafts reaction cannot take place in aryl amines. It can take place in alcohols, all those things. In alcohols or amines also, it is very difficult, because this aluminum chloride, it reacts with that nitrogen and oxygen there and forms a complex. So it is difficult. So this reaction doesn't take place over there. Next is the mechanism of Friedel-Crafts alkylation. So first one is the formation of a electrophilic substitution. So here also it is the same kind of reaction. Instead of your acyl chloride, here we are taking a alkyl chloride. So that is the only difference between a Friedel-Crafts alkylation and acylation. Okay, first we are taking a alkyl chloride and treating it with and your Lewis acid catalyst aluminum trichloride is reacting with it and forming a complex. That was the first one, and that from the complex the chlorine will be the chloride ion will be lost, and it results in the formation of a electrophilic species CH3 plus. Okay, that is where carbocation is formed. So next step is electrophilic attack on aromatic ring. So this electrophile will be added across the double bond. Here across this double bond, CH3 plus is added, and it forms a bond here. Okay, it forms a bond here, and which makes it to lose its aromaticity, which makes the ring to lose its aromaticity. Okay. And next one, third step is a restoration of aromaticity. To restore its aromaticity, a proton will be lost. So this proton will be lost as H plus and resulting in the form aromatic ring. Okay. So our fourth step is the regeneration of the catalyst. So the proton reacts with the aluminum complex and forms the HCl and aluminum trichloride. So you are getting back your catalyst. So the overall reaction is this one. So your benzene reacting with the electrophile alkyl cation and losing its aromaticity, and to regain its aromaticity it loses its H plus, it loses a proton and forms a alkyl derivative. And so next, what are the limitation of Friedel alkylation? So the alkyl halide, the halide must be either an alkyl halide. So the starting material, it should be an alkyl halide. It cannot be a vinyl halide or aryl halide. So why we cannot have a vinyl or aryl halide is when the electrophilic species is formed, so it becomes more reactive, so it is very unstable in condition of your vinyl or aryl halide. So we cannot take that as a starting material. So starting material has to be only your alkyl halide. So next one, so alkylation reaction are prone to carbocation rearrangements. Okay, if it is based on its stability, the carbocation rearranges itself. So based on the stability of the carbocation, the effectiveness of an alkylation takes place. Okay, so the percentage of the product is depending on the stability of the carbocation forming. Next, the deactivated benzene are non-reactive to Friedel reaction. And next, overall alkylation can be a problem since the product is more reactive than the starting material. Okay, so if we are taking an alkyl products, okay, so if the alkylated product is in more quantity, then it is more reactive when compared to a benzene. Okay, the toluene is more reactive when compared to benzene. So over alkylation, there is a mono, tri substituted, all those things. So they are more reactive when compared to the starting material. So to avoid these things, we can usually have a excess of benzene in the reaction. And in case of aryl amines, as we have seen in the Friedel acylation, the same reaction here. The aluminum trichloride is more reactive, and if we have a aryl amine, the Lewis acid first initially instead of reacting with the alkyl halide, it reacts with the nitrogen, and so it forms a complex there. So we cannot carry out this reaction in case of that types of compound. Thank you. I hope this you have understood what is Friedel reaction. Thank you for watching this video. I will meet you in the next video.